All right, so yesterday we talked about, again, remember this last quiz, we were graphing and that's how we found solutions. And yesterday we made that transition over to, we're going to find these solutions algebraically now by factoring. We will get into completing the square, we'll get into the quadratic formula, but we wanted to spend some time on factoring because, again, it's just a big part of Algebra 1 and Algebra 2. So yesterday we talked about greatest common factor. And hopefully most of you noticed that this is what you do when you have a binomial. So binomial meaning two parts. Both of them had an x, right? So there weren't three terms necessarily, not counting the zero. So this is a binomial. You can always use greatest common factoring. So a couple of those questions on the Blooket, like it was like if you divide out a 2 or divide out a 3, things get a little easier. But in general, just know that that's going to be greatest common factor will be like a binomial. Then we talk about what I don't know, facetiously call normal factoring because I don't know what else to call it. But this is like our easy factoring that the Blooket really focused on, where hopefully you can just look at it and you're like, yes, that's the one. It's where it multiplies to the last number and adds to the middle number. Once you find those factors, you can just write it and you use that zero product property. So today what's different, we're just going to do example 3. And notice it says factor and solve a trinomial where a is not 1. So when we're talking about our general form of a quadratic equation, that's that ax squared plus bx plus c. And so a not being 1 means that leading coefficient in front of the x squared. And so if you can divide out a greatest common factor, that's great, because then maybe you could get this back to 1 and then you can do the normal factoring. But a lot of times you can't do that, so we have to do an extra step. So we can't just do it like we did example 2 where we list out the factors of the last number. We have to add some more steps here. So I'm going to go through this a couple times. But our first step, when you have something not equal to 1 up here, you need to actually start by multiplying the first and the last number. So I'm going to put steps here on the side. Multiply A and C. So what's 2 times 5? 10. All right, so now we list these multiples. So list multiples. And so now it is sort of like what we did yesterday. We're going to list the multiples of 10 and find the 2 that add to 11. So it'd be 1 and 10 and 2 and 5. And which of those 2 add to 11? 1 and 10. So these are going to be our multiples. So once you find those multiples, this is also where it's different. So in this method, and this is, I guess I'll call this factor by grouping. Factor by grouping. In factor by grouping, once you find your multiples, you're going to split, I'll put that in quotations, B term. So what I mean by that is this term in the middle here, instead of writing 11x, what we're going to do is we're going to write 2x squared, and then it doesn't matter the order here, but I'm going to put plus 1x plus 10x plus 5 equals 0. Let's take a minute here. Do you guys see how 1x plus 10x gets us back to this 11x? You see that? Okay, so why this is called factor by grouping is because now what I have done is I've created 2 groups. Much like example 1 yesterday now, you have these 2 groups and you can think about greatest common factor. So what is the biggest thing that I can pull from 2x squared and 1x? An x, right? I can't pull a number, but I can pull out an x. So let's pull out an x here. And if I pull out an x here, that would leave me with 2x plus 1. You guys all see that? Okay, what's the biggest thing I can pull from 10x plus 5? A 5. So I'm going to put a plus 5 here because it's a positive 5. Don't just put 5, put plus 5. And so 10x divided by 5 would be what? 2x. And what's 5 divided by 5? 1. Before I go on, does everyone see where everything's coming from? I'll do this twice at least. So this is like factor by grouping where I grab 2 different greatest common factors now. Notice if you multiply these back in, you'd get back to this line. And if you added these like terms, you'd get back to that line. So now that I have this, do you guys see how these 2 match? That means that's going to be one of my factors. 2x plus 1. So take the matching factor. That's one of your factors. Does anyone know what my other factor is? Not 1. What's left here? Yeah, x plus 5. Now I'm factored. This is factored by grouping. This is mathematically super sound. It's good stuff. The last one, I'll do the slide and divide method. But now that I have this factored, I'm good to use that zero product property. So now I split these off. I have 2x plus 1 equals 0, and I have x plus 5 equals 0. So here I can subtract 1. So I have 2x equals -1. Divide by 2 on both sides. Sorry, my handwriting is getting smaller and smaller. So I get x equals -1/2. That's one of my solutions. And over here, I'd subtract 5 from both sides, and I'd get x equals -5. So on Go Formative, I would list my answers -1/2, comma, -5. So there's quite a few more steps here. And if you weren't 100% with the factoring yesterday, today's going to be a little bit challenging. Be a little bit challenging probably anyways. Let's see one more, and then I'll take some more questions. So part B, I'm going to again do by factor by grouping. So my first step, I won't write it again, but it's going to be to multiply that A and C. So I multiply 3 times -12 is what? -36. I want to list my factors of -36. So if it needs to add to a negative number and multiply to a negative number, my smaller number is going to be positive. My bigger number would be negative. So 1 and -36. 2 and -18. There'd be 3 and what else? 36 divided by, that's 12, right? -12. It's not divisible by 4. Yes, it is. 4 and -9. I really don't need to list all these, but I'm being, again, a perfectionist. 6 and -6. Okay, I did not need to list all of these because which is my factors that I need? What adds to -16? 2 and -18. So you could have stopped here. You all know me. So now is this step where I'm going to split my B term. So again, different from yesterday, I'm going to split my B term. So I'm going to take 3x squared. I'm trying to color code here. And then instead of -16, it does not matter which order you do these in, by the way. You could switch the order and you'd still have good things happen. But I'm going to leave it as plus 2x minus 18x minus 12 equals 0. And in this way, I've created 2 groups. So here are my 2 groups. What can I pull from 3x squared plus 2x? A single x, or 1x, which would leave me with 3x plus 2. What can I pull from -18x and minus 12? 6. And pull a negative. Anytime you have a negative in the middle, pull a negative. So I'm going to pull out a -6. And in that way, that would leave me with a 3x plus 2. Because your goal here is to make these 2 match. Because if those don't match, you don't have one of your factors. They have to match. So as soon as they match, you know that's one of your factors, 3x plus 2. And what's my other factor? X minus 6. Some of you are seeing it. As soon as you're factored, we're good to use that zero product property, split these off. Some of you can do this in your head. Some of you are like me and need to write out the steps. So over here, I would subtract 2 to start. So I'd have 3x equals negative 2, and then divide by 3. So I'd get x equals negative 2/3. And over here, I'd add 6, so I'd get x equals 6. So on GoFormative, I would enter my answer negative 2/3, 6, and not as an ordered pair, just as a list. All right, pausing here. What questions do we have about factor by grouping? Does everyone at least see where things are coming from? This is one that takes practice, I think. As long as you can see where things are coming from, you have to kind of internalize that process, those steps yourself. It's very mathematically sound. It's my favorite method for factoring these. There is a quicker method, and I will show it to you, even though I don't love it, because it's not as mathematically sound. When I say mathematically sound, what I mean by that is every line here is equal to the line above it. That is mathematically sound. That's how math works. You want to make sure each argument is correct. That's how programming works too. This next method is fudging that a little bit. So I'll call this the slide and divide. Bless you. Slide and divide. And a little caveat, a warning with slide and divide. This only works if there is no greatest common factor ahead of time. Okay, so if you have a greatest common factor that you don't notice at the beginning and you don't factor it out, this method does not work. Now, chances are, first of all, that won't happen on your quiz, or if it does, I would give you a warning. I can't say the same for your homework. So this might not work 100% of the time, and that's why I really don't like this method as much. But it is like a nice little trick. So first of all, is this in standard form? No, I need to move this 17 over by subtracting 17 to start. Just a reminder, that can still happen. But that's good because 3 times 15 would have been a big number, and I don't really want to deal with that. So this is going to be 3x squared plus 5x minus 2 equals 0. So for this method, for slide and divide, you are still going to multiply your first and your last numbers. So what's 3 times negative 2? Negative 6. It's multiplying to a negative, but adding to a positive. That means my smaller number is going to be positive. My bigger number, my smaller number will be negative. My bigger number will be positive. So factors would be 1, negative 1, and positive 6. Negative 2 and positive 3, and that's it, but I already found it. And these are my factors. Okay, here's where slide and divide is different. Guys ready for slide and divide? So slide and divide, the setup is you have your two factors. So we're going to jump right to the factor, and this is where this is not mathematically sound. What you do is you take this leading coefficient, but instead of like this x squared, you're just going to put a 3x. So put a 3x and a 3x. And then you take these factors, minus 1 plus 6. This is not mathematically sound because if you multiply this out, you do not get back to this original. Okay, that's why I really don't like this method. But can you guys see how I could reduce this second factor? What could I divide out? Just divide out a 3. And so this is just magic happening because you usually can't just divide out numbers from an equation. You can't do that without doing something to the other side. But if you divided out a 3 here, then you would have 3x minus 1. And then you'd have x plus 2. And now if you did FOIL this back out, you would get back to this original. 3x times x is 3x squared. 3x times 2 is plus 6x, minus x is 5x. And then negative 1 times 2 is minus 2. So it would get back to this original, rather. So this is the factored form. This is like the part where you're just kind of making stuff up. That's slide and divide. But once you've done your slide and divide, you can then split this off. You can make this 3x minus 1 equals 0, x plus 2 equals 0. Here I would add 1, so I'd have 3x equals 1. Divide both sides by 3, and I'd have x equals 1/3. And over here I'd subtract 2, and I'd have x equals negative 2. So it'd be 1/3, comma, negative 2. This is slide and divide. As a reminder, you can always check your work. If you go to your y equals, clear out anything that's in there. Type in this equation with the equals 0, not the equals 17. So 3x squared plus 5x minus 2. And then if you look at your graph, we have this parabola. It's kind of hard to see the 1/3, but you can see that that's happening between 0 and 1. It's about 1/3. And then it's happening at negative 2. It crosses the x-axis. So again, you can check your work that way. I don't care which method you use. Again, the slide and divide only works if you don't have greatest common factors. I don't think you do today, but I guess I don't remember for sure. Let me post your assignment for today. And then